We're Team Rookie PMO. We are doing the challenge number 10, the design management app, the change management. Our team consists of 4 people, Mosung, me, Stacy, Ran, and Ya. So here's our scenario. Cecilia, who's a project professional, she's managing a team of people and approves the content of documents uploaded, and she also needs to report back to their supervisors on a daily basis. She needs a very clear interface with accurate information to track progress and make informed decisions on these documents and changes. Stacy, on the other hand, is a client. She wants to visualize the live snapshot of the project progress. Also, she wants to understand the challenges of risks. Kiki, who's on the other hand, the engineer on our team, she wants to track the project progress. Also, she needs to submit and fix some of the project proposals.
We design a smart user interface with well-designed menu of options which help us clearly and easily track the progress of each project. At the bottom of the page, we design the buttons for users to access the analytic graphs and perform some essential operations, such as approval or changing the information. The workflow of the management app is presented in this diagram. We have designed a couple of subpages that allow the users instantly access the most important information from a huge number of managed projects.
In terms of the project dashboard, we have a backend server to capture the changes from new input data, and then we store the changes into the database server on either Power Apps or other BI software. Once we got the database in hand, we can start visualizing the changes of data from different views. We present the simulated workflow in the Jupyter Notebook, and each module is defined in the slide. Considering the change of new data, it can be a string containing information about data changes or new uploaded files. The backend server is responsible for capturing the difference of changes and send the information to the database. The database serving on cloud or local will store the data for regular usage. The dashboard is designed as a graphical user interface for visualizing the modified changes. The demo code for the workflow is fully presented in Python as shown in the form of Jupyter Notebook. We simulated the change of data, designed the functions to capture these changes, store the data changes in the database for visualization, and also make prediction about estimate program time and also the cost.
As for the backend processing part, it consists of 3 different functions. Inconsistency detection, we want to capture potential duplicates and invalid inputs. Moving on to correction automation, we want to use smart algorithms to correct data entries automatically, including deleting some duplicate entries and also fix invalid inputs without human input. Also, we want to keep a reporting system where it flags entries that need more attention to managers. We are adopting a hierarchy-based algorithm. So for duplicate rows, we delete the entries automatically. And secondly, for similar rows with maybe review status changed, we will update the database and also flag it to the manager so they are aware of the changes. And also thirdly, for similar rows which are potentially duplicates, we will flag it to the manager so they can make a decision around there.
Here is the example of log of changes. We can clearly visualize the number of changes of different data type, such as approval from manager and information modification from contractors, subject to various length of period. Considering the users modifying the data, we can also trace them from the database. So overall, we defined a complete data structure recording every detail of data changes and are able to provide more analytic graphs. While looking into the prediction process, a new metric defined as the forecast time minus actual time over forecast time is used to showcase the level of accuracy of the estimated program time, and is also the target for later on regression process in order to acquire the prediction of the actual program time. After investigating the dataset, possible features that can affect the accuracy of the estimated time are the status, change type, requester, priority, type, and also the scale of the initial estimated time. For example, the habit of a certain requester might be that they always overestimate the program time by 5 days, or a high priority one can in most cases require more time than the estimated. After obtaining the dataset, a sequence of data processing skills are applied to achieve the prediction functionality. The one-hot encoding is to change categorical value into numbers for later on processing. Data standardization and principal component analysis is to cut down the number of features for the regression model. And then finally, the polynomial regression is to find the best match for this case and to predict the actual program time based on the PCA transform data. The similar approach can also be applied to the cost in order to predict the actual cost required for the program. The first question from the judge is, how can our Python script be integrated into a user-friendly interface? In fact, Python is a glue language and is powerful for running data-driven algorithms. It contains many powerful packages for developing good user interfaces on web or local server. We aim at solving the problem and not stick to using only one language. Python script can be executed in the Linux terminal on any cloud server. For consistent usage of data processing with Python, we use no-hub command to keep backend server processing incoming data changes. Considering other tasks integrated with third-party app, such as Power App, we expect to use their integrated functions as much as possible. In addition, the second question from the judge is, what additional data could be captured to enable more accurate predictive analysis? The number of features seems to be sufficient, especially after one hot encoding. Every categorical value breaks down into many more features. However, the data for each category is not enough to ensure a high accuracy model. For example, for each requester, there is only around 10 sets of data, which is too few to be generalized into a model to predict the program time and cost. The third question from the judge is, how can this predictive analysis allow for better informed decision-making? So once the prediction for actual program cost and time is acquired, changes regarding the allocation of resources to each program can change. And with a wiser way of allocating workforce and asset, the general project management can be more efficient.